Hello again. So today we are going to talk about system of linear equations. This is the a unit that follows the linear equation and graphing section or unit. So basically, whenever you have a pair or more than a pair, 3, 4, 5 linear equations, when considering all of the equations at the same time, considering them together, they're called the linear system. Now you could have a system that is not linear. That could be that one equation is a line, the other one is not a linear, is a quadratic or a cubic or a different function, which you will learn later on and at different levels. And then those systems are called non-linear system, but we don't deal with that in this section. All right. A couple of things. Basically, what is it that we're looking at? We're looking at when we're dealing with solving a system, linear system, basically what we want is all points of intersections of the lines, the two lines or the three lines or the four lines, or that's the graphic representation. I'm going to show you how that is. Or you're looking at basically, which is the same thing as saying that let's come up with the same ordered pair, however many we can come up with, that are common to all the equations. They satisfy, so the way I wrote it is that they satisfy the equation of all equations in the system. So let's look at the first kind of couple of examples in terms of notation. What does the system look like? Now, this one that I just drew for you, wrote down, I randomly chose two lines, two equations. They are linear. They look like, and they are written as a line, either a general form or a slope-intercept form. It doesn't matter, but they are two lines, and this is called a system of two equations. And if you have three variables, and this is two equations and two variables, notice that we have one variable here and we have one variable here, and these are the same two variables we're going to look for and we're going to find, and that's what the whole point is. We want to find the same values of x and y that basically satisfy both equations. But you could have a system of three equations, and if you do have that, then in order to be able to solve that, you must have three unknowns. Now, they don't represent a line anymore, and that's not a linear system. That's a different thing. And then you go four equations with four unknown and five unknowns and so forth and so on. You could have a system that is it's got many equations in it, as many as 20, 30, 40, 50. It doesn't matter. That's at the higher level. But for the purpose of this course or this unit, we are just going to deal with the system of two equations with two unknowns, and that's what that we will do. Okay. So how does it look like graphically? So let me give you an example. Suppose I have this grid and we draw a line, just a random line L1, and we have another line. Let's draw another line. That's line 2. Okay. If we want to solve the system where these two lines are in that system, what we are looking for is the point of intersection of the two lines. And where do they intersect? Right there. That is the point of intersection, and in this case we can actually come up and write them as the coordinate, whatever the coordinate is. In this case the coordinate will be 0, 3, but really if there was another line that crosses the bottom, let's say this one right here, here we go, this is L3, and this coordinate will be between the L1 and L3. The point of intersection of the two will be that one, and in that case the coordinate will be, we don't know exactly because it's not exact value there, so I'm just going to call it x and y, but that is the coordinate we're looking at, and that is the solution to the system. So all of these guys, there are solutions to the systems that are written in ordered pair or that when you grab these points and plug them back into either one of these equations of the lines, doesn't matter which line you put them in there, if they're in a system, they should satisfy those equations. Simple as that. So now let's look at the part where we want to know how many possible solutions we're going to have for any linear system. Well, let's look at this. We kind of know this already, but let's look at it again. Well, it depends on the lines, right? So let's look at it graphically. Let's suppose I draw two lines. One is here, L1. There's another one, L2. All right? They are intersecting. And if they're intersecting, that means that you notice that the chances are, that's very true, that slopes are different, radically different. All right? So number one, if their slope different, their slopes are different, then you have one solution. For sure, because that's the coordinate that they intersect, and that's the solution to the system. So we got two lines, L1 and L2, and that's what you will say. So number of solutions is one solution when the slopes are different, or they could be perpendicular. That's still considered to be slopes, different slopes when they're perpendicular to each other as well. Number two, let's suppose that, what if their slopes are the same? What does that mean? What kind of a line is that? Well, let's draw a couple of lines. I'm going to draw one line here. Just call that L3. And I'm going to draw another line right beside it. And what I'm trying to kind of get at is that these two lines supposed to be, so I'm going to put a couple of arrows on that. And in geometry, when we have it set up like this, that means the two lines are parallel. So if you have two slopes are the same, we know from last unit, so same slope, it means L3 is parallel to L4. That's the notation for parallel lines. And so here's a question. Do they intersect? No, they do not intersect. There are no solutions. So no solution. When they are parallel, that means they have the same slope. So same slope, no solution to the system. And then the last one is that when you have the same line that is being basically created by a multiple of the first line. Okay, so one line is written as your x plus y equals to 2. And the second line is a multiple of the first line, and that will create something very interesting. So the second line, let's suppose that we're going to multiply the first line by 2. Here it is. Well, when you do the math for the second line, notice that they're all multiplied. I can divide everything by 2. And if I do that, I get x plus y equals to 2, which is the same as that. So the two lines are actually the same. So when you have a situation like that, the two lines, we call them coincidental lines. That means they are on top of each other. Basically, they are the same line. The name coincidental lines basically means that they're the same line. And when you have a situation like that, so it's basically the same line. So if I use this L4 as an example and draw the L5 on top of it, I'm going to use a dotted line, but it's the same line, by the way. It's just for notation purposes I'm doing that. They're the same line. That means every single point in one equation will work for the second, because it's the same equation. They're not different. And we say, if that happens, how many solutions do you have? We have infinitely many solutions, because the lines, they go forever. All right? So that's basically it.